Hi all, electrical engineer, Igor Ekimov, is with you. Today we will look at the WinAPEX 268B current clamp multimeter. Despite its small size, it has almost all the functions inherent in a modern multimeter. These clamps can measure both direct and alternating current. At the same time, it has high current sensitivity, which allows the device to be used to detect leakage currents. And this is ideal both for repairing electrical wiring at home and for finding faults and leakage currents in a car. In multimeter mode, it can measure voltage, resistance, capacitance, temperature, and also tests diodes, looks for phase and background of alternating current. It allows you to rotate the screen, which makes it easier to measure current with both your right and left hands. We'll talk about all this further in the video. If you are interested in other videos on electrics, then subscribe to the channel and press the bell. Special thanks for your likes and reposts. The device is supplied in this packaging. The packaging is quite rigid and was not damaged during shipment. Let's open it. The device is in such a convenient case. We take it out. The case has a loop that makes it easy to carry. Open the case. Here is the device itself. And here are the wires. These are measuring wires, a thermocouple, and a cord for charging the device. The wires are standard, quite soft. They have plugs for connectors and probe protection, which protects them from corrosion. Here is a wire with a thermocouple for measuring temperature. We'll talk about it a little later. And here is the charging cord. This is a Type-C connector. This is a USB connector. To charge the device, this cord must be connected to any USB connector with a voltage of 5 volt. In the device, we connect the cord here. Open the rubber plug and connect the cord. There is also a button for activating the clamp current measurement mode. There is a speaker here. We have a flashlight here. And here is the cover under which the battery is located. Let's see. There is a 750 mAh lithium battery and a voltage of 3.7 volt. This is how the battery is connected. We collect. On this side there is a trigger for opening the pliers. At the end there are connectors for connecting cords. On top is the display and control buttons. There is film on the display. I'll take it off so it doesn't interfere. I draw your attention to the compact dimensions of the device. Here are the standard 266 pliers that I have been using for a long time. Look at the difference in size. And here are modern pliers from the GVDA company, which I recently reviewed. Our device is also smaller. Thanks to the compact size of the device, they can fit into a lot of places. How to use the device is intuitive. The red button is to turn on the power and go through parameters not related to current measurement. Turn it on. The device undergoes self-diagnosis and displays the following lines. This is the basic screen. Let's start with the most interesting function of the device, measuring direct and alternating current, as well as checking leakage currents. To measure current, you need to press the side button. We use it to select current measurement modes. To start, I selected the DC current measurement mode and the display shows DC. The device selects the measurement range itself. In this mode, you can select the most sensitive mode with 3 decimal places, and the less sensitive with 2 decimal places. Before measurements, the readings must be reset by pressing the 0 button. So I set a more sensitive DC measurement range. We have 3 decimal places and a DC icon, which means direct current. The laboratory power supply is 1 amp. Before measurement, reset the readings to 0 using the 0 button. Let's measure it. Here we have 1.59 amperes. We can also measure the leakage current. To do this, We place pliers on both wires at once. And we see that the current is near zero. Let's reset it to zero before measurements so that we can have a more accurate one. And now we put it in. We got 20 milliamperes, although it should be about zero. If we measure one wire, we have a current in the region of 1 ampere. Let's simulate leakage current. We'll use an additional wire to do this. Here we have put together a diagram. We have two wires coming from the negative terminal, and one from the positive terminal. Reset. Here we measure it. Ours shows a leak of 0.56A. Where is this leak? And this is a leak in this additional wire. The device can measure direct current from 5 milliamps, in steps of 1 milliampere. At the measurement limit up to 6A and in steps of 10 milliamp, at the limit up to 60 amp. The maximum current that the device measures is 60 amp. I don't like that even without measuring the current, the device readings range from 20 to 40 milliamp. Therefore, they cannot accurately measure small leakage currents when measuring direct current. To turn the indicator over, hold this key for a long time. Now our indicator has turned upside down. Use the side key to switch the device to the alternating current measurement mode. By default, it includes the most sensitive AC current measurement range. In this range, it measures current from 2 milliamp in 0.1 milliamp steps. If the current is greater, then the device selects the measurement range itself. It measures the RMS value of alternating current up to 60 amp. In this range, the device can be used to measure small leakage currents. The measurement principle is the same as in an RCD, in a residual current device. We simultaneously enclose both wires in pliers, the neutral and the phase. If currents of different values flow through them, the device will show the difference in the values of these currents. That is, a leak occurs in the load, the value of which was measured by the device. The same device can be used to search for leaks in three-phase circuits. We simultaneously connect three-phase clamps and a neutral wire, and measure the leakage current in the load. We can also use the device to check the symmetry of the load in a three-phase circuit. By clamping three phases without a neutral wire in pliers, the device will show the unbalanced current. In order to measure the circuit current, we need to turn on the device to measure alternating current. We capture a phase or zero, and it shows that 8 amp is consumed. In order for us to measure the leakage, we need to capture both wires, both zero and phase. We captured both phase and zero. We get 14 milliamp leakage. If we had a leak of more than 30 milliamp, our automatic circuit breaker would have tripped. Now we have a little less, 7 milliamp. This way we can measure the leakage current in our wiring. Now let's see what other parameters the device can measure. We press the red button, and we switch to the DC voltage measurement mode. This is told to us by the DC icon and the V symbol, which means voltage measurement. Let's measure the voltage in this battery. To measure, we connect the probes. We connect the red one here. We connect the black one here. We measure 3.8 volt. This battery is dead. You can throw it away. Let's measure the voltage of the battery. 1.47 volt, which is normal. The device selects the measurement range itself. The maximum voltage that it can measure is 1000 volt. When the voltage that the device can measure is exceeded, it displays the OL value. Input impedance of the device on all ranges, 10 mega ohms. Press the button again and go to the AC voltage measurement mode. The AC icon tells us this. The fact that the device readings are different from zero is not a defect. These are pickups from the probes of the device. If the probes are shorted, the device readings will reset to zero. The device measures the RMS value of alternating voltage up to 750 volt. The device also selects the measurement limit itself. At the minimum limit, the device measures voltage with an accuracy of 1 millivolt. Let's measure the voltage at the outlet. We measure. And the voltage in the socket is 230 volt. Press the red button again and enter the resistance measurement mode. Measurement range from 0.1 ohm to 10 mOhm. It is worth considering. When measuring small values, up to 600 ohms, you need to short circuit the probes of the device in order to see the measurement error at the moment. We have zero error here. And when measuring the value, you will need to subtract this error. When measuring a resistance of more than 1 mOhm, stabilization of the device readings may take several seconds. This is our resistance of 1 ohm. We measure. Here is one resistance. A second resistance. A third resistance. A fourth. As we can see, all four resistances are around 1 ohm. Press the button again and get into the mode of checking diodes and continuity of the circuit. In the dialing mode, a signal sounds when the resistance between the probes is less than 50 ohms. As you can see, it measures latency. Wait a while for the device to respond. When testing diodes, voltages up to 3 volt and currents up to 1 milliamp are used, which allows you to test almost any LED. At the same time, the voltage at the PN junction is shown. The highest voltage is needed to light up the blue LED, so we'll check it. Here we have connected the LED. It lights up and the voltage at its junction is 2.55 volt. We turn it over. And it shows OL, which means infinity. This way you can determine the pinout of any diodes. Press again. And go to the capacitance measurement mode. We can measure capacitances from 1 picofarad to 60,000 microfarads. Before checking capacitors, they should be discharged. This can be done by shorting the terminals if the energy in the capacitor is negligible. Let's check the ceramic capacitor. We close the terminals of the capacitor. Press the 0 key to reset the readings. We measure the capacity. Ours shows 15 nanofarad. Let's try an electrolytic capacitor. We also close the conclusions. Let's connect. Ours shows 102 microfarads, which corresponds to the parameter of this capacitor. It is 100 microfarads. Press the red button again and go to the frequency measurement mode. Let's connect an external generator. So I connected the generator. Here I have 30 Hz. We can lift. Here are 40 Hz, 50 Hz, 150 Hz, 250 Hz. As you can see, the device handles frequency switching well. Turn off the device. Let's measure the frequency of the voltage in the outlet. Here's 50 Hz. The maximum input voltage for such measurements should not exceed 250 volt. At such high voltages, the device cannot be connected for more than 10 seconds. To avoid damage, press the button again and switch to the temperature measurement mode in degrees Celsius. By default, it measures the temperature with a sensor inside the device. As you can see, it shows a temperature of 30 degrees. This temperature is usually a little high, since it heats up the device board. Therefore, it is better to connect an external sensor. With an external sensor, the device measures temperatures from -20 to 1000 degrees. Let's measure the temperature of the skin of your hand. So I clamp the thermocouple, and my hand temperature is about 35 degrees. Which is approximately true. If we press the red button again, we will find out the same temperature, only in Fahrenheit. We took out the thermocouple and pressed the red button again, and returned to the original state, when we display 4 lines. Let's look at the rest of the buttons. If you hold this button for a long time, you turn on the flashlight. It is not bright, but in complete darkness it can help with measurements. Long press this button again and turn off the flashlight. A short press on this button, as we know, resets the readings to 0. Let's look at the hold button. If we press it, we freeze the device readings. In this case, we can disconnect the device from the circuit being measured, and these readings will remain on the device display. Press the hold button again and return to the initial state. If we hold the button for a long time, we go into the screen brightness adjustment mode. With this button we can adjust the brightness of the screen. Once adjusted, hold the button again for a long time and exit the adjustment mode. With this key we switch to the magnetic field detection mode. Here we are getting closer to the monitor. As you can see, this is the maximum signal. We relate. To check if there is voltage in the panel, we just need to turn on the EF function and bring it to the panel. The closer we bring it, the more often the LED flashes and the buzzer sounds. So we see that there is tension. Unfortunately, the buzzer cannot be turned off, but the buzzer in this device is rarely used. Using this function, you can check the presence of a phase in the electrical installation or junction box that you are going to work with. Sometimes this function helps to find shallow electrical wiring. Press this key again. This is the mode in which the phase can be found. Connect the red probe. At the same time, the device must be held. Let's see. Here it shows the phase. But here the device does not respond, which means there is no phase. At the same time, it is necessary to hold the device, since without this the device does not respond to the phase. Turn it off. The device has an automatic shutdown function. If this device is not used for 15 minutes, it will go into sleep mode. At the same time, press the power button again and it will turn on again. This is such an interesting compact device with great capabilities. An important difference between this device and similar ones is its small size and high current sensitivity, which allows it to be used for measuring leakage current. And in other respects, it is not much inferior to other middle-class devices. It can be useful for repairing wiring in the house and car. If you have any questions, ask them in the comments. You can also ask questions to the seller of the device. I left the link in the description. Write your opinion about this device. Share the video with those who may be interested in this device. Subscribe to the channel and press the bell so you don't miss new videos. Like, and see you in new and old videos.